Dear Professor, I would like to submit my homework for sharp. Number one, about explain and design post kinematics or aid after uh, or and effector. For the task is to explain and design a frame, DH table, and post kinematics or and effector. Next, we can introduce the definition of frame. The frame is the structural support for the robotic arm. For the image, the frame is represented by the base and the joints that connect the links. The frame provides stability and allow the robotic arm to move in a controlled manner. The joints and the linkage of the robotic arm are labeled in the figure with different colors, colored coordinate system. For the axis, the purple is the axis. The x-axis is blue. The pupil is the axis. The x-axis is the axis is green, and the y the y-axis is blue. The following are the principles for assigning king frame, like this, like this. One, first is base frame. The labeled the z 0.1, y 0.1, and x 0.1. They are usually fixed to the center of rotation of the robotic arm base, like joint 1, which the z-axis oriented along the rotation axis. The theta 1 is the rotation angle. The second is joint coordinate system. Each joint co- corresponding corresponds to a coordinate system with ZA. For example, is Z 0.1, Z2, Z3, Z4. They are correspond correspond to the subsequent to the joint axis, and the x from for such as x point 0.1, the x2, x3, and x5 and x4 along the direction of extension of the connecting rod. And for the y-axis, y2, y3, y4, and y 0.1 are determined by the right hand rule, by the right hand rule. And for the three, is end effector. For the end effector frame, its main have a tool such as gripper fixed at the end of a robot arm, which position and attitude need to be disturbed according the post kinematics. Next is next is the DH table. The DH table is parameter table needs to con- contain four parameters. The A the A is connecting road length. Its mean is distance along axis, and the alpha is mean connecting road turns angle. Its mean rotation angle around the axis, and the next is D. D is connecting road offset. It means the different it means is the distance along from the Z shaft. And the third is mean joint angle. For the catenage, one is A is 0, 2 A is L2, 3 is L3. For the alpha, 1 is 0, 2 is 90, and 3 is 0. For the D, the 1 is D2, and the 2 and 3 are 0. For the third, the 1 is 31, 31, 32, and 33, and oh no, 31, 33, and has the 30M like this. The last is positive kinematics. The positive kinematics obtains the end effector's position with respect to the base coordinate system by multiplying the transformation matrix of the coordinate system at each level. The transformation matrix for each joint, we can use this to calculate. We can use the T T01 and T12 and T23. We can calculate this and got the total transformation matrix like this. Use together uh, together multiply. For this is H01. We can calculate this and go to the last result like this because is the first joint. And next we can set the 1 2. We can got the second joint. We calculate got the last result. And again, the H2 3 we can got for the third joint. 2 uh, coordinate 2 and 2 2 3. Yes, got here. And the homogeneous matrix is the last result like this. Okay, we can quote the 3, 4, the last result like this. If like use the last harmonies, we can quote the H04. We can quote the last result like this. This is calculate the positive kinematics calculate how to calculate. And there have an example calculations. We can use the theta 1 is like this, theta 3, theta m, and the d2 like this. We can quote the from this, the end position is like this, the x equal this, and y equal this, and z equal this. We can quote the last result is the position from the x, y, and z. We can quote this. Okay, okay. This is my or introduction of homework for shop. Number one, about explain and design post kinematics or and effector. Thank you, sir.